Hi everyone. In today's lesson, we're going to talk about another rule of differentiation called the product rule. Here's the definition. So the product rule, if f of x and g of x are two differentiable functions, then the derivative of f times g of x can be defined as this. So let's analyze what this is. So this part here, f of x times g of x prime, you should notice that prime notation means the derivative. So this first piece is the symbols for the derivative of f of x times g of x. So the formula to find the derivative is, if we'll call this our first function, and we call this our second function, it becomes the second function times f prime of x means the derivative of the first function, plus f of x, which is our first function, and times g prime of x, which is the derivative of the first. So that's the formula in a nutshell. And I kind of just said these words right here. In other words, the derivative of a product, this is your product, can be found by taking the second function times the derivative of the first, plus the first function times the derivative of, I wrote first there, derivative of the second. So there's a simpler explanation rather than figuring out like first and second. It's kind of like a little rhyme, and it'll help us with another type of derivative. So it's helpful if we can understand it this way. I like to call this first function my high function, and the second function my low function. So what I'm going to say is g of x is my low, f prime of x is my d, or derivative, of my high, plus my high function times the derivative, d, of low function. So it's a little bit of a rhyme, low d high plus high d low. The d stands for the derivative. So low function, which is my second function, times the derivative of the high, or the derivative of the first, plus high d low. It has a nice little ring to it, and we're going to use this same ring for the next type of derivative function. So let's try to get used to that. So let's do a couple of examples. So here is how the product rule would show itself. Say we have a function f of x that is the multiplication of two separate functions. So notice we're multiplying x squared plus 3 times negative 5x minus 4. We can use the product rule for that. But what you could do technically in this scenario, you could actually use the power rule, what we learned a couple days ago. But how? Well, first we have to make it a polynomial. So couldn't we just double distribute? So let's rewrite this. X squared times negative 5x squared is negative 5x to the fourth. X squared times negative 4 is negative 4x squared. 3 times negative 5x is negative 15x squared. And 3 times negative 4 is negative 12. So if we combine our like terms, we have negative 5x to the fourth, negative 4x squared minus 15x squared is negative 19x squared minus 12. So now that we have our simplified f of x in polynomial form, we can simply use the power rule. So take the 4 multiplied in front. So f prime of x now is negative 20x, decrease the power by 1. Take the 2, multiply it by the 19, so negative 38. Drop the power down by 1, 2 goes down to 1. And the derivative of a constant, 12, is 0. So this would be my derivative. Now, in an example like this, it may be faster to double distribute and then use the power rule versus going through this complicated formula. But I want to show you how this formula can be used and we can still get the same answer. So here's my first function. Here's my second function that I'm multiplying together, right? So my first function, I will call our f of x. My second function is my g of x. And I call my first function my high function. and my second function, my low function. And the formula that I want us to get used to rather than f of x and g of x. So f prime of x is low times d high, or high prime. So low times high prime, low d high, plus high times d low, or the derivative of low, which is low prime. So this is really the preferred formula that I want us to memorize. So let's see if we can put it into practice. So we're going to take the low function, which is negative 5x squared minus 4. So that's low. Now we're going to take the derivative of high, d high, or high prime. So the derivative of this function is just x squared. The derivative of that is 2x. And the derivative of this constant 3 is 0. So just 2x. So low d high plus the high function, which is x squared plus 3, times the derivative of the low function. So my low function is this, and the derivative of this constant is 0, so it's just the derivative of this piece. So negative 5 times 2 is negative 10, and the x stays. Now we're going to have to do some multiplying to get it to look like this, but we can do that. So let's distribute the 2x. It's okay that it's on the wrong side. We can still distribute. So 2x times negative 5x squared is negative 10x to the third. And 2 times negative 4 is negative 8x. And then plus, we can distribute the negative 10x in. That would be negative 10x to the third minus 30x. So if we combine our like terms, negative 10x to the third plus negative 10x to the third, that will give us negative 20x to the third. And then negative 8x and negative 30x add to a negative 38x. So two scenarios, same thing. Honestly, with this problem, I find this way to be easier, but I wouldn't be showing you this product rule if I didn't think you needed to know it. So that brings me to a more complicated example like, say, number 3. Number 2, you can absolutely still do the same thing. You can distribute, and then use the power rule. But what I'd like us to do is use actually the product rule for this one. So let's get practice with that. So our first function, we're going to label as my high, and my second function, we're going to label as my low. And we're going to write down the formula for the product rule. Low times d high, or high prime. That's what it means, d high. Low d high plus high times d low, or low prime. So let's fill in. So low, we're just going to repeat what our low function is. So negative 2x to the fifth minus 3 times the derivative of high. Here's high. The derivative of 4x to the fifth is 20x to the fourth. The derivative of x to the third is 3x squared. And the derivative of 2x is just 2. So that's low d high plus high. All I'm going to do is rewrite my high function. And then times the derivative of low. So the derivative of low is just the derivative of this piece because the derivative of a constant is 0. So the derivative of negative 2x to the fifth is negative 10x to the fourth. Now what's great about the product rule is that we can leave it just like that. We don't have to simplify it. So maybe this way is a little bit easier than doing your double distributing or triple distributing and then, combining like terms when this is a totally acceptable answer. Now, let's go back to example number 3. With a problem like example number 3, you have no choice but to do the product rule. Why? Because you're multiplying two things together where this is your first function and this is your second function. And there's no way that you can raise this to the negative third power, then multiply it by that. It gets a little too confusing. So we're going to do our high and our low, and we're going to write the formula. So f prime of x is low times d high plus high times d low. So low d high plus high d low. Remember, d stands for derivative. Low times the derivative of high plus high times the derivative of low. So f prime of x, we're going to rewrite our low function, which is 7x minus 1. Now the derivative of high, here's my high function. You should notice that this is actually a chain rule. So I'm going to use a bigger set of parentheses, and I'm going to use a different color when taking the derivative of the high. So remember chain rule, take the exponent, bring it in front. So negative 3 times 4x squared plus 2, keep the base. Now decrease the power by 1. So negative 3 minus 1 is negative 4 times the derivative of the inside. Well, we know the derivative of a constant is 0, so we just take the derivative of this piece, which is 8x. And all of that is my derivative of high. So it's really important that you put that derivative of high in its own set of parentheses. Plus now, high, all I'm going to do is rewrite my high function. And now d low, the derivative of low, nice and simple. The derivative of 7x is just 7, and the derivative of a constant is 0, so it's just times 7. So this is how you can leave your final answer. So what's tricky about this one is that there may be a chain rule involved. So I'm going to get you started on number 4, but I'd actually like you guys to try to see if you can finish this one for homework. So the first thing that I notice is obviously that I'm multiplying two things together, so I need to use the product rule. But I notice that I have radicals and not exponents. So what I'm going to do is first rewrite this as a fifth root as a power of 1/5 instead. And as a fourth root, I'm going to raise it to the 1/4 power instead. So first, I'm going to rewrite it. And then second, let's label this as my high function and this as my low function. So why don't you actually see if you can do this now and then hit resume when you're ready for the answer. Okay, so f prime of x is low times d high plus high times d low. So my low function is negative 5x to the third plus 9x minus 1 to the 1/4. That's my low. Now I have to take the derivative of the high. Well, my high function looks like there's going to be a chain rule. So I'm going to put the 1/5 in front, keep the x, 3x squared plus 1, keep the base. Now decrease this 1/5 by 1. So 1/5 minus 5/5 is negative 4/5. And then we're going to times the derivative of the inside. And the derivative of the inside is just 6x because the derivative of 1 is 0. So that's low d high plus my high, which is 3x squared plus 1 to the 1/5 times my d low. Let me try to see if I can fit this in here. My d low would be this function. I'll use a different color. So let's take the derivative of that using the chain rule. So the 1/4 goes in front. We keep the base, negative 5x to the third plus 9x minus 1. And now we're going to take the 1/4 and subtract 1, or 4/4, and that gives me negative 3/4. And we also now have to take the derivative of the inside. So this also has to be multiplied in there. The derivative of negative 5x to the third is negative 15x squared. And the derivative of 9x is just 9. And the derivative of a constant is 0. So ugly, but all of this is your final answer. And don't worry, we'll go over this tomorrow in class. All right, have a great night.